Hari ke okey ke? Mau. Penat.
Dah.
Dah. Aku cakap dulu. Assalamualaikum. We are from Group 2D. Today we are going to present about MEMS. Okay, here the group members, which is Abdul Wakin, Muhammad Amir Farhan, Muhammad Taufik, Nur Alia, and one Muhammad Nur Hakim. There are 4 points to present about which is introduction, background history, application, and future trends. So let's start with introduction of MEMS. Microelectronic mechanical system MEMS is a process technology used to create tiny integrated device or system that combine mechanical and electrical components. They are fabric using integrated circuit IC batch process technique and can be ranged in the size from a few millimeters from millimeters to millimeters. MEMS consists of mechanical, microstructure, microsensor, microallocator, and microelectronics. However, MEMS is just not about manufacturing of mechanical components or making things out of the silicons. MEMS is a manufacturing technologies. There are no MEMS transistor. So we continue with background history.
Next. History of MEMS from 1916 until 1980. MEMS were first proposed in the 1960s but not commercialized until the 1980s. Engineers and the scientists wanted to use integrated circuit fabrication techniques to make tiny mechanical systems, which could, if necessary, be connected to electronic circuits on the same chips. One of the first commercial applications of MEMS was the tiny nozzle assembly used in the cartridges of inkjet printers. Each of the nozzles in an inkjet printer's print head consists of a hollow chamber. Inside, ink flows in is heated with tiny electric heating elements and is expelled through a port. The chamber and all its features are created using the same photolithography techniques as an integrated circuit. Done.
Okay, it continues in 1982. Automotive airbag system, which had been proposed in 1950s, were introduced using MEMS sensor to detect a crash. The Analog Device Corporation elaborated this idea, producing an accelerometer for airbag system in 1991, where the mechanical and electronic portion were integrated on the same chip. The accelerometer chip detects the sudden increase or decrease in speed that occurs during a crash. The same company later introduced a gyroscope on a chip capable of working with an automobile's global positioning system to create more accurate maps and direction for drivers. The MEMS approach also decreased the cost of ownership of each sensor, mainly by eliminating manual assembly steps and replacing them with a parallel batch fabrication. Next.
Application are developed where miniaturization is beneficial to consumer product, aerospace, automotive, biomedical, chemical, optical display, wireless, and optical communication. Sensors are a major application for MEMS device. Three primary MEMS sensor is pressure sensor, chemical sensor, and inertial sensor. MEMS sensor can be used in combination with other sensors for multisensory application. For example, a MEMS can be designed with sensor to measure the flow rate of a liquid sample and at the same time identify any contaminant within the sample. A pressure sensor is a device consisting of a mechanical component and electronic component. MEMS pressure sensor use a flexible diaphragm as the sensing device. One side of the diaphragm is exposed to a sealed reference pressure and the other side is open to external pressure. The diaphragm moves with a change in the external pressure. MEM in automotive industry. MEM pressure sensor sense, monitor and transmit tire pressure, fuel pressure, oil pressure and airflow. MEM initial sensor. MEM initial sensor are designed to sense a change in an object initial and then convert to transduce initial force into a measurable signal. Okay. MEM accelerometer. The simplest MEM accelerometer sensor is an initial mass suspended by a spring. The mass is deflected from its nominal position as a result of acceleration. This deflection of the mass is converted to an electrical signal as the sensor output. Okay, MEM gyroscope. A gyroscope is generally a spinning wheel of disc with a free axis allowing it to take any orientation. Some gyroscope use a vibrating structure rather than the traditional rotating disc to determine orientation. Here you can see some example MEM initial sensor in automobile. Okay, thank you.
Future trends. In the 20th century, technology and system advancement were astounding and unprecedented. Most of these advancements are discrete in nature, with semiconductors progressing in integration and system progressing to suit discrete markets, needs in computing, telecommunication, and consumer service. For example, the 21st century, on the other hand, will be defined not only by the integration of technologies such as microelectronics, photonics, RF and wireless, and MEMS, but also by the consumer and telecommunication product in one package. The I/O, as shown in the diagram below for automotive, handheld, cost performance and high performance system make up the single largest component of system packaging. Together, they are capable of unimaginable. First, digital performance of the other of 10 GHz digital computer clock speed. RF performance of the other of 100 GHz RF wireless speed. Third, optical performance of the other of terabyte per second of 10 terabyte per second. Optical bandwidth in micro-miniaturized system made possible by microsystem technologies described in this chapter. Representative MEMS products. In jet printheads, MEMS market share 31%, airbag accelerometers 25%, inertial sensors excluding airbags 30%, pressure sensors 12%, RF system 3%, optical device 1%, other 15%. That's all. This the picture. Thank you. Okay dah.